Welcome to Topcast, and today for a reaction video. Thanks to Ben, I was pointed in the direction of Professor Michael Levin, who I have heard of before, but I haven't consumed much of his content, so to speak. But I was asked to watch the interview that he gave with Tim Ferriss, and I found it very interesting. And the more I explored and dove deeper into Michael Levin's work, I found that he was making a lot of sense on some really interesting, hitherto unknown areas of biology, I suppose. He's making progress, it seems. He's doing some interesting experimental work on things like worms and how worms can regenerate. And this might have all sorts of implications for longevity research, let's say, or curing cancer, and just trying to make the human body more robust until such time as we can download this wetware into something artificial that's going to be able to last longer than what our biological bodies can last. But in the meantime, people like Michael Levin, scientists like Michael Levin, are doing important work, I think, on this front. And as we will come to hear, because I'm going to be reacting to two of the interviews that he's done recently about this, he speaks about how not all the information that codes for an organism, so to speak, is there in the genome. At least, maybe a better way to put it is it is not all about the genome. And so he does experiments like cuts off the head of a worm and then it regrows another head. It can regrow two heads. He can apply electricity to these living organisms in order to cause them to grow appendages or not. And then if the appendage gets removed, it will regrow the mutated appendage, so to speak, even though the genome itself hasn't been changed. He'll explain it a lot better than what I can throughout this interview. So I can't really assess just how good this research is, or if there are any problems with it, because I'm not a biophysicist or a biologist in general. I did do biophysics for a couple of semesters when I was doing my undergraduate physics degree, but 2 semesters is not enough for me to consider myself an expert by any means. So although we're going to listen to some of him talking about his own area of expertise and the research he's been doing, which I'll think is for the good, and I'm sure I'll repeat myself, say, more power to him in doing lots of this research. The reason why I was pointed towards one of his interviews, the interview with Tim Ferriss, is because he then started to make comments about computation more broadly, physics more broadly, consciousness broadly, and cognition and learning and this kind of stuff. And so I found that interesting as well, but for a different reason, as we'll come to. Now, in trying to understand where he was coming from, because listening to him talk to Tim Ferriss, who is an accomplished interviewer himself in the podcast space, it was like I was trying to play catch-up. They were having a conversation that I was joining partway through, it seemed. So I needed more background information. So I had to go to Michael Levin's extensive website where he has lots of articles that he writes about his own research papers. And so that's good. He's got explainer articles for his professional research papers. And so he is very prolific. He has written, dozens, maybe hundreds of research papers. And then he's gone to the effort of actually writing articles in simpler language in order to explain what those research papers are about. So this is all fantastic stuff. And it allows people like me who like to nitpick things to actually hone in on where I think there might be areas of disagreement, if any, which can always be interesting to explore. So that's what I will be doing today. I'm going to begin, however, with another interview that I watched with Michael Levin. It seems like a lot of these scientists, I don't know if there must be some kind of podcast network where these interviewers seem to cycle through the same guests at about the same time. So if you see a scientist appear on Joe Rogan, soon after they're going to be on Lex Fridman, and soon after they're going to be on trigonometry, and soon after they're going to be on Tim Ferriss, and so it goes on this conveyor belt kind of thing. And when you hear them on one, you don't really have to bother listening to them on the other, because they say kind of the same thing. So in any case, I listened to the Tim Ferriss one first, and I thought, well, I better listen to a couple more as well. And a chief one among those was, he appeared twice on Lex Fridman, but we're just going to listen to the beginning part of Lex's second interview with Michael Levin. the biologist Michael Levin, who not only talks about biology because his degree, I think his undergraduate degree was not only in biology, but it was also in computer science, or at least maybe he has 2 degrees, one in biology, one in computer science. So he likes to talk about algorithms, and some of the things he says about algorithms are really interesting as well, let's just say. I keep using this word interesting to cover both things that I find fascinating because I hope they're true and I agree with them because it's going to help humans' ability to repair their bodies over time. So that's great. But also I'm using interesting in the, I'm not quite sure that that's correct, strictly speaking, or that disagrees with what I've understood about physics, for example, elsewhere, or philosophy, let's say. So we'll get into all of that. Let's begin by listening to a little bit of his interview, just a short amount with Lex Fridman. And knowing me, being verbose, I'm not reading from notes or anything like that. I'm going to end up talking for a long time because I want to get through just this bit of Lex Fridman and then a substantial part of the Tim Ferriss interview. But I certainly won't get to the entire thing because his interview with Tim Ferriss goes for well over an hour and a half. Okay, so let's just pick up Lex Fridman and Michael Levin.
The following is a conversation with Michael Levin, his second time on the podcast. He is one of the most fascinating and brilliant biologists and scientists I've ever had the pleasure of speaking with. He and his labs at Tufts University study and build biological systems that help us understand the nature of intelligence, agency, memory, consciousness, and life in all of its forms here on Earth and beyond. This is the Lex Fridman podcast. To support it, please check out our sponsors in the description, where you can also find links to contact me, ask questions, get feedback, and so on. And now, dear friends, here's Michael Levin. You write that the central question at the heart of your work, from biological systems to computational ones, is how do embodied minds arise in the physical world? And what determines the capabilities and properties of those minds? Can you unpack that question for us and maybe begin to answer it?
Well, the fundamental tension is in both the first person, the second person, and third person descriptions of mind. So in third person, we want to understand how do we recognize them and how do we know, looking out into the world, what degree of agency there is and how best to relate to the different systems that we find. And are our intuitions any good when we look at something and it looks really stupid and mechanical versus it really looks like there's something cognitive going on there? How do we get good at recognizing them? Then there's the second person, which is the control, and that's both for engineering, but also for regenerative medicine. When you want to tell the system to do something, right? What kind of tools are you going to use? And this is a major part of my framework, is that all of these kinds of things are operational claims that you're going to use the tools of hardware rewiring, of control theory and cybernetics, of behavior science, of psychoanalysis and love and friendship. Like, what are the interaction protocols that you bring, right? And then in first person, it's this notion of having an inner perspective and being a system that has valence and cares about the outcome of things, makes decisions and has memories and tells a story about itself and the outside world. And how can all of that exist and still be consistent with the laws of physics and chemistry and various other things that we see around us? So that I find to be maybe the most interesting and the most important mystery for all of us to, well, on the science and also on the personal level. So that's what I'm interested in.
The only thing I'd say there is, okay, so he's working in part at least, or he's interested in consciousness. And although he says to Tim Ferriss at some point that he's not actually researching consciousness, and the only reason he ever speaks about consciousness is when someone asks him about consciousness. But here we're beginning with a deep dive apparently into this relationship between consciousness and the third person perspective, otherwise known as the hard problem of consciousness. And I hate to be a wet blanket, but what I do hear him say later on is no different to anything that I've heard elsewhere. And that shouldn't be some criticism, because I don't hear anything new from anyone on this topic, because, well, there hasn't been a breakthrough. And I don't have any particularly new ideas on my own. I did make that video that I refer to quite often. Are consciousness and creativity the same thing? I don't know. Michael Levin will describe himself later on as some kind of super panpsychist. And panpsychism is the idea that everything from fundamental particles through to everything in the universe has consciousness or some first-person aspect to it. An unfalsifiable idea. But then again, all at the moment, theories of consciousness are unfalsifiable. Me saying that consciousness and explanatory creativity are two sides of the same coin is also, it doesn't really add anything. I don't think I'm adding anything much by saying that, but I am drawing a line between the special kind of consciousness and creativity that people have and every other entity in the universe. Now, Michael Levin's going to disagree with that and disagree with this idea that we should have binaries operating. He's very much against drawing distinctions between things, it seems to me. He insists on a continuum of consciousness, a continuum of problem solving, a continuum of intelligence as well. And it, to my listening, but again, we will have to hear it from his own mouth at some point, it leaves no special place for humans. And this is a theme on Topcast recently when I am talking about the work of many researchers, be they researchers into animal psychology and neuroscience. They want to say that, well, humans are just an especially advanced kind of ape. It's just a continuum between us and chimpanzees and dogs and rats and cockroaches and so on. And also, on the other hand, the researchers into AI who likewise say there's nothing special about humans. Computers of various different kinds of complexity are conscious and creative and one day will exceed us in consciousness and creativity as well. In either case, they're both arguing, well, there's nothing special about humans. And this is what, of course, it's a political movement as well now. This is what environmentalism is very much about, this idea that humans aren't special except insofar as that they are particularly dangerous. And so I think it's important that there be at least some people out there who aren't religious, because religious people do this very well. Religious people are very good at arguing for the sacredness, the specialness, the uniqueness of human beings, of people. And there's something lost in the purely scientifically rational community who want to continue with the Copernican revolution in a way. The Copernican revolution was supposed to take away this idea that people are special, central, or a hub in some sort of way. And as I often argue, we can have both. We can have the bits of religion that are good when it comes to this, namely, people are really special and unique and cosmically significant, if you like. But we don't have to believe anything on insufficient evidence, as Sam Harris would say. We don't have to take on board bad explanations or the supernatural, the magical, in order to argue this. The only other school of thought that I know about that has modern adherents, I suppose, are the objectivists, the Ayn Rand objectivists, who very much exalt man, the human, the power of reason and creativity, while also being committed to reason, to a kind of vision of the world that does not include anything magical or supernatural or to make grandiose claims. But so I want to try and explain how humans genuinely are important, genuinely are unique. I want to preserve that idea because I think it's important, not only because it helps us to understand that we are special and can make the universe a better place, but it's also an explanation of what is going on right now. Why do those skyscrapers appear in New York and in London and in Sydney and everywhere else, that there are great buildings, great monuments to civilization? Why is there poetry? Why is there art? Well, it's because human beings are different to other species. Now, this is an important problem, research project to work on because it intersects with AGI and morality and more besides, epistemology. So I think it's important to really emphasize the uniqueness of human beings. It's not to say that other things aren't unique as well, but this is a unique problem that will require a unique solution. And saying that we're on a continuum with all other animals doesn't solve that problem at all. But I'm getting way ahead of myself and I'm critiquing things that Michael Levin hasn't even said yet. So let's keep going.
So your work is focused on starting at the physics, going all the way to friendship and love and psychoanalysis.
Yeah, although actually I would turn that upside down. I think that pyramid is backwards. And I think it's behavior science at the bottom. I think it's behavior science all the way. I think in certain ways, even math is the behavior of a certain kind of being that lives in a latent space. And
That's a huge claim that mathematics is the behavior of a certain kind of entity that lives in another space, like the abstract Platonic realm or something like that. So that's highly mystical, highly speculative, and I don't think it helps in order to say this kind of thing. And it is the same kind of error as reductionism. But it is a form of reductionism, what he's explaining here. He doesn't want to put physics at the base of everything. This old idea that many, many people refer to, that, well, chemistry is nothing but a form of physics. It's just what atoms are doing. And biology is nothing but what chemicals are doing. So we're just reducing things down to ever more fundamental sciences. And on this view, therefore, psychology is nothing but biology, and sociology is nothing but psychology, which is nothing but biology, which is nothing but chemistry, which is nothing but physics. And physics is maths or something like that. And so you have this hierarchy, okay? But the worldview that I tend to explain here is that you can have fundamental ideas in any discipline. There are fundamental ideas in psychology. There's fundamental ideas in epistemology, in mathematics, in physics, in chemistry. There are fundamental ideas because it turns out there are fundamental laws. Now, the laws of physics do reign supreme. That's the best explanation that we have. Stuff is made of matter and it cannot transgress the laws of quantum theory, or general relativity, if you like. That's just the explanation of how things move and what energy is and orbital paths or whatever, collisions, whatever you happen to, however you want to phrase this. But it does not mean that by studying physics ever more closely, by studying the laws of physics ever more closely, that you're going to get a deeper understanding of evolution by natural selection, necessarily, or how explanatory knowledge is created, or what morality is, or anything like that. That is the mistake of reductionism. So merely inverting this isn't a huge revelation. It's just the same kind of error to say everything reduces to, let's say, behavioural science. Better to just say, well, behavioural science may be more significant than what most people think. Let me go back just a little and recap there what he just said.
I think in certain ways, even math is the behavior of a certain kind of being that lives in a latent space. And physics is what we call systems that at least look to be amenable to a very simple, low agency kind of model, and so on. But that's what I'm interested in, is understanding that and developing applications, because it's very important to me that what we do is transition deep ideas and philosophy into actual practical applications that not only make it clear whether we're making any progress or not, but also allow us to relieve suffering and make life better for all sentient beings, and enable to enable us and others to reach their full potential. So these are very practical things, I think.
So he says that he wants to relieve suffering for all sentient beings. Yeah, we can all be on board with that. And so where this becomes really important is if people begin to claim that sentience actually genuinely is panpsychic in some way. In other words, everything has some degree of consciousness and perhaps some capacity to suffer. Depends on what kind of panpsychist you are. But some may say, for example, that the electron has a degree of consciousness and potentially the capacity to suffer. And then ants have more capacity to suffer, and then rats more, and dogs more, and then humans more. And it's just this continuum of capacity to suffer, which means that then there is a moral requirement upon those of us who can think and reason through these things to not step on an ant, because that's some amount of suffering and therefore some amount of evil. And perhaps if electrons can suffer in some way, we have a moral requirement to do something about that. So it can lead to problems, okay? And we can just say we don't know, We don't know what consciousness is and we don't know how suffering works, but we should err on the side that just maybe some of these complicated creatures with nervous systems are the things that can suffer. Now, we'll come back to, Michael Levin's particular take on this kind of panpsychism and the fact that he doesn't like to draw lines. He doesn't like to draw a line where either side of the line, this thing can suffer and can't suffer. Or either side of this line, this thing has a mind and the capacity to understand and reason and problem solve in the way that we say that people do and can't. Now, just because we can't point to the line, or no one can give an account of where the line is between things that have minds and things that don't have minds, does not mean such a line doesn't exist. It's just an open problem. We'll come back to this.
Behavioral science, I suppose, is more subjective and mathematics and physics is more objective. Would that be the clear difference?
The idea basically is that where something is on that spectrum, and I've called it the spectrum of persuadability. You could call it the spectrum of intelligence or agency or something like that. I like the notion of the spectrum of persuadability because it's an engineering approach. It means that these are not things you can decide or have feelings about from a philosophical armchair. You have to make a hypothesis about which tools, which interaction protocols you're going to bring to a given system, and then we all get to find out how that worked out for you, right? So you could be wrong in many ways. In both directions, you can guess too high or too low or wrong in various ways, and then we can all find out how that's working out. And so I do think that the behavior of certain objects is well described by specific formal rules, and we call those things the subject of mathematics. And then there are some other things whose behavior really requires the kinds of tools that we use in behavioral cognitive neuroscience, and those are other kinds of minds that we think we study in biology or in psychology or other sciences.
Why are you using the term persuadability? Who are you persuading and of what?
Well,
in this context.
Yeah, the beginning of my work is very much in regenerative medicine, in bioengineering, things like that. So for those kinds of systems, the question is always, how do you get the system to do what you want it to do? So there are cells, there are molecular networks, there are materials, there are organs and tissues and synthetic beings and biobots and whatever. And so the idea is, if I want your cells to regrow a limb, for example, if you're injured and I want your cells to regrow a limb, I have many options. Some of those options are I'm going to micromanage all of the molecular events that have to happen, right? And there's an incredible number of those. Or maybe I just have to micromanage the cells and the stem cell kinds of signaling factors. Or maybe actually I can give the cells a very high level prompt that says, you really should build the limb and convince them to do it, right? And so which of those is possible? I mean, clearly people have a lot of intuitions about that. If you ask standard people in regenerative medicine and molecular biology, they're going to say, well, that convincing thing is crazy. What we really should be doing is talking to the cells, or better yet, the molecular networks. And in fact, all the excitement of the biological sciences today are at single molecule approaches and big data and genomics and all of that. The assumption is that going down is where the action is going to be, going down in scale, and I think that's wrong. But the thing that we can say for sure is that you can't guess that. You have to do experiments and you have to see, because you don't know where any given system is on that spectrum of persuadability. And it turns out that every time we look and we take tools from behavioral science, so learning, different kinds of training, different kinds of models that are used in active inference and surprise minimization and perceptual multi-stability and visual illusions and all these kinds of interesting things, stress perception and memory, active memory reconstruction, all these interesting things. When we apply them outside the brain to other kinds of living systems, we find novel discoveries and novel capabilities, actually being able to get the material to do new things that nobody had ever found before. And precisely because I think that people didn't look at it from those perspectives, they assumed that it was a low level kind of thing. So when I say persuadability, I mean different types of approaches. Right, and we all know if you want to persuade your wind-up clock to do something, you're not going to argue with it or make it feel guilty or anything. You're going to have to get in there with a wrench and you're going to have to tune it up and do whatever.
This is a theme that we will come back to over and again. Michael Levin has idiosyncratic ways of using language that make it very difficult to critique what he's talking about, because he is applying this behavioral science lens onto things that behavioral science does not normally deal with. And so everything is being looked at through that lens. And so therefore, he talks about persuadability and a continuum of persuadability at that. Everything is persuaded to some degree or other. So if you're driving a car, it's not like you are turning the steering wheel, which then is connected to the front tires, quite normally front wheels, which then turn in response to you turning the steering wheel. Michael Levin would phrase this as you are persuading the car to turn, persuading the wheel to turn, and so on. And so this is, as I say, an idiosyncratic way of talking. If you want to explain why it is that the car goes left rather than right when you turn the wheel, very few mechanics would want to say that, well, it's to do with the degree of persuasion. So there is, if everything is able to be persuaded in this way, it means that the word persuasion, when you want to actually use it to talk about what happens in, let's say, high-level epistemology and arguments and discussions between people, what's actually going on there when someone takes on an argument, when someone listens to an explanation and are convinced the explanation is the best one they've so far heard, we generally say that person has been persuaded. However, if the word persuasion also applies to a broken clock when you fix it, a car when you turn the steering wheel, an individual cell or atoms, or something else where you're not actually having an argument with it, then we need a new kind of word to explain what's going on when a person hears a good explanation and thinks that it genuinely is a good explanation, better than anyone they've ever heard before. Hitherto, we've had this word, persuaded. I was persuaded. But that word loses all meaning if we go down this road of using the word persuasion to label a spectrum of different things, where at one end it's just about a mechanical effect, where if someone lights a match next to a forest which is very dry, the forest is persuaded to catch fire. Now, you can say this, but it's just... He will come to also his critics. Now, his critics, which I haven't read, but he talks about his critics in various interviews. And his critics say that he's, in his words, committing a category error, that he's applying terminology to things where that terminology shouldn't be applied because it's an imprecise way of phrasing things. And I cannot but help to agree with them, that there are other ways to talk about this. If you want to talk about what happens to a clock when you repair it, you can do that in mechanistic terms without using the word persuasion. Why one wants to shoehorn it in? Well, I know why, because this is the kind of thing that podcasters like. They like to hear this. It's like everything has the capacity to think. It's more than what it brings in. Now, he's going to say that it doesn't bring in magic or supernatural stuff or whatever, but it gives a very human, it imbues everything with consciousness. It imbues everything with this panpsychist idea. So he seems to be coming from, for want of another word, a foundation. He has this foundation. The foundation is, well, everything's conscious. And given that everything's conscious, now let's take what is usually used when we're investigating consciousness, which is namely the tools of psychoanalysis in order to try and understand what another person is thinking, why they're behaving in a particular way. At least this is one reason for the existence of psychoanalysis, right? We're trying to understand why it is people behave the way they do. So psychologists and psychiatrists, they engage in this kind of thing. So if you really take seriously the idea that everything is consciousness, and everything has a motivation or something like that, or can be persuaded, then yeah, you're just going to take the tools or the language from behaviour science and apply it to everything else. By the way, this critique has absolutely nothing in my mind to do with his excellent experimental work. I think that is all for the good, and we will come back to that. So let's keep going.
If you want to do that same thing to a cell or a thermostat or an animal or a human, you're going to be using other sets of tools that we've given other names to. And so that's now, of course, that spectrum, the important thing is that as you get to the right of that spectrum, as the agency of the system goes up, it is no longer just about persuading it to do things. It's a bidirectional relationship, what Richard Watson would call a mutual vulnerable knowing. So the idea is that On the right side of that spectrum, when systems reach the higher levels of agency, the idea is that you're willing to let that system persuade you of things as well. In molecular biology, you do things, hopefully the system does what you want to do, but you haven't changed. You're still exactly the way you came in. But on the right side of that spectrum, if you're having interactions with even cells, but certainly, dogs, other animals, maybe other creatures soon, you're not the same at the end of that interaction as you were going in. It's a mutual bidirectional relationship. So it's not just you persuading something else. It's not you pushing things. It's a mutual bidirectional set of persuasions, whether those are purely intellectual or of other kinds.
So if you have an interaction with a dog, it's going to persuade you as much as you persuade it. I think that this is better couched in terms of just learning. I mean, yeah, you're going to be different after you interact with a dog if you have a pet, anyone. Okay, but he seems to say that, there is, again, this spectrum, but you can have your mind radically changed by the non-living. I don't think that it's that this term persuasion, again, it's like I can talk about how, if as an astronomer, one is to point their telescope to some part of the sky and to see a supernova, that will have a profound impact upon, well, you as an astronomer, because you will have discovered it, that's one thing. But also, if your observations lead you to come to understand supernovae in a way that no one did before, that's also going to have a profound impact on you. To say that the supernova persuaded you, however, of something can be regarded as true in a kind of vacuous sense. It's not so much that the supernova has persuaded you, it's that you've persuaded yourself. You've created some knowledge yourself about that thing out there. That thing out there, Michael Levin, of course, will disagree, doesn't have agency. This word agency is another one he uses where it's on a spectrum as well. Everything's on a spectrum, it seems, for Michael. And agency is one of these things. Agency has been, just like intelligence, and I've said this over and again, especially recently, has been used by the tech community in such a way that it's lost all meaning. What agency used to mean was a term for why people with free will would do a thing. They would behave in a way that was different to all other systems known, including animals. Animals appeared to be driven purely by instinct, and I would say they still are. Their behaviours are largely, almost entirely coded within their genome somewhere or other. And so they're not thinking about a spectrum of possible futures in the same way that we are. They're not explaining anything to themselves. They don't have agency. What we have is agency. We have free choice and we can create new choices. We have a special kind of agency. Now, if you want to say, no, we're not the only things that have agency. Everything has agency down to electrons. They have an intrinsic motivation of some kind or other. Okay, you can say that. Just like Karl Popper, I'm not going to get into deep discussions about terminology, but it just means that we're left with this problem of what makes people different. And hitherto, we had a whole vocabulary of language which would enable us to talk about this: creativity, free will, agency, the ability to be persuaded, all of this stuff. And so if you take all of that away and you say, well, it doesn't only apply to people, it applies to everything, and the way in which it applies to everything is I'm going to subtly change what we've understood these words to mean so that they can be used to describe these non-human animals, these non-living things, then we're left more confused than what we were before. Because not only do we not solve the problem of what's going on with those other entities, living or non-living, human or non-human, we don't actually improve our understanding of those things, because after all, we're just trying to explain why it is that they behave in the way they do. But we're also still left in the same place with respect to how is it humans achieve the special, unique capabilities that they do. It's just a bit of a language game. And I'm happy to use whatever words anyone likes, but I'm interested in these problems. Like, there are some words out there which genuinely do have ambiguous meanings, which we can talk about in terms scientific, and we can neatly distinguish them from terms less scientific and more in the realm of philosophy, morality, something like that. One word is attraction. Attraction is one such word. It is absolutely the case that we can talk about something like the sodium ion, Na+, being attracted to the chloride ion, Cl-. And so you get the salt unit in a salt crystal coming together because there is literally an attraction, an electrostatic attraction governed by the laws of physics between these two things. That is able to be explained by the laws of physics. At the same time, we can also talk about people being attracted one to another. How, in general, heterosexual people, boys being attracted to girls, men being attracted to women, that kind of thing. But it's a different kind of attraction. It's not the same positive, negative kind of attraction. It's not a physical force in the same way. It's not described by Coulomb's law, for example. And so we have this other word which allows us to refine what we're talking about there. We could talk about love, for example. Now, you might very well want to say, if you're a scientist who wants to say something profound and interesting, you might say, love actually permeates everywhere. Love is not a thing that exists solely between human beings. It's also a thing that can exist between dogs when they mate or they're attracted to each other. It also exists between cells when they stick together to form a multicellular organism. It even exists between sodium ions and chloride ions. When they come together because of love. Love is just attraction after all. Now, you could say that, but just that we now have a problem of what is this thing that brings together a husband and a wife, for example. Now, if you say it's love, but then you're unable to differentiate between that unique subjective feeling that people have and what's going on with sodium and chloride ions, I think we have a problem. And if you're wanting to say it's all the same, just a matter of degree, that doesn't actually solve anything. It just moves the problem into a different realm, so to speak, of trying to explain, well, we haven't explained anything. We're just saying they're identical and it's a matter of quantity.
So in order to be effective at persuading an intelligent being, you yourself have to be persuadable. So the closer in intelligence you are to the thing you're trying to persuade, the more persuadable you have to become. Hence the mutual vulnerable knowing. What a term.
Yeah, Richard. You should talk to Richard as well. He's an amazing guy, and he's got some very interesting ideas about the intersection of cognition and evolution. But I think what you bring up is very important because there has to be a kind of impedance match between what you're looking for and the tools that you're using. I think the reason physics always sees mechanism and not minds is that physics uses low agency tools. You've got voltmeters and rulers and things like this. And if you use those tools as your interface, all you're ever going to see is mechanisms and those kinds of things. If you want to see minds, you have to use a mind, right? There has to be some degree of resonance between your interface and the thing you're hoping to find.
Well, again, I'm not really sure what this word agency means. The voltmeter has low agency. I just say it has no agency. It's got no choice in what it does. There are errors involved. The voltmeter's not perfect, but that's not because it's choosing to show a value that isn't actually the value of the potential difference between two things, which is what a voltmeter does. So I don't know what this means. And this notion of error will come back again later as well, as if to say that when errors occur, this indicates something more than just that an error has been made, that a mistake has been made, that the laws of physics allow for errors to occur. It's as if there's some kind of will behind the fact that errors sometimes occur. That's the sense that I get from what Michael says, that he doesn't even, I don't hear him speak about the term error much, but some of what he is bringing into, for example, why it is that sometimes algorithms don't give you what you expect out the end. He doesn't couch that in terms of, well, perhaps an error was made, which is one way of looking at things. But again, we'll come to that.
You said this about physics before. Can you just linger on that, like expand on it, what you mean? Why physics is not enough to understand life, to understand mind, to understand intelligence? You make a lot of controversial statements with your work.
I think that's entirely uncontroversial. I guess there are certain physicists still, or people who have an interest in physics but don't really know much about physics. There are a lot of these people as well, who will say that the only game in town is physics. Physics is very important because it constrains what it is possible for all other systems to do. So if you're a chemist and you think that you've found a new kind of molecule, but the molecule is impossible to keep together given what we know about the laws of physics, then you've likely made an error somewhere. So if your chemical theory disagrees with a known law of physics, that's a problem. It could be that you're right, but more than likely you've simply made an error. Of course, we cannot explain everything. There's an important reason why lots of different subject areas exist. It's because we do have this notion of emergence and that you can understand the simple rules that operate in other domains. I explained before why it is, for example, that, sodium ions and chloride ions will stick together. It comes down basically to electrostatic attraction. And that electrostatic attraction exists because the sodium atom is such that its outermost electron is only tenuously held by the protons in the nucleus. And so it's easily able to lose that electron. And if it loses an electron, which it does quite often, which it does necessarily when it forms an ionic compound, then it becomes positively charged. A sodium atom under normal circumstances is neutral, and because of the distance between the nucleus and its outermost valence electron, it loses the valence electron sometimes and can react with something. It can give away that electron actually, transfer it entirely to something like a chlorine atom. And once the chlorine atom gets that extra electron, it gets an extra negative charge and it becomes Cl minus. Cl minus, Na plus, they stick together. That rule emerges out of deeper laws of physics, deeper laws of quantum theory. But you don't have to, if you're a chemist and you're trying to explain this or trying to understand this or trying to make predictions within your own field, you don't have to refer to the laws of quantum mechanics if you don't want to. You can just talk about these valencies. All throughout the periodic table, you can predict what kind of molecules and compounds will form and what the ratio of the different elements will be or the different atoms will be in any given compound because you know these simple rules without ever thinking about the Heisenberg picture or the Schrödinger wave equation or anything like that. You don't have to worry about any of that. And so too in biology, you don't have to refer to the laws of physics, even though the laws of physics are there and will constrain what can happen. But I don't know, like this notion that physics could explain everything. No. In fact, that's a deep theme running through, of course, the work of David Deutsch. Michael Levin, I think he uses a version of David's argument at one point about, the copper atom argument, which I won't go over again, but, this is the idea that it would be ludicrous to try and explain what happened during World War II in terms of fundamental particles and the laws of motion.
That's one of them. Because there are a lot of physicists that believe they can understand life, the emergence of life, the origin of life, the origin of intelligence using the tools of physics.
Yeah.
In fact, all the other tools are a distraction to those folks. If you want to understand fundamentally anything, you have to start at physics to them. And you're saying, no, physics is not enough.
Here's the issue. Everything here hangs on what it means to understand. Okay. For me, because understand doesn't just mean have some sort of pleasing model that seems to capture some important aspect of what's going on. It also means that you have to be generative and creative in terms of capabilities. And so for me, that means if I tell you this is what I think about cognition in cells and tissues, it means, for example, that I think we're going to be able to take those ideas and use them to produce new regenerative medicine that actually helps people in various ways, right?
So to understand something means you need to be creative and generative. I don't know what that means exactly, but he kind of says, well, it has to lead to some kind of technology. But this just isn't true. To understand something means you are able to, subjectively, appreciate the account that has been given of something, to grok the explanation. Eventually you get to a point where all terms become circular. But understanding an explanation, understanding an explicit explanation is important in science. But you can also say, well, I understand how to ride a bike without being able to explain, in words how to ride a bike. an example I've used many times before. But you can have an understanding of all sorts of things without it being generative or creative. These are just other words for developing an explanation, I suppose. But if the standard is that some technology has to come out the other end of your understanding, that's simply false. Because I can have an understanding of the English language and write poetry and whatever else without generating some new technology. Or I can have an understanding of what's on my kitchen table or something like that. There are many things that I can have an understanding of, which doesn't mean I'm going to generate something at the end of that necessarily.
It's just an example. So if you think as a physicist, you're going to have a complete understanding of what's going on from that perspective of fields and particles, and who knows what else is at the bottom there. Does that mean then that when somebody is missing a finger or has a psychological problem or has these other high level issues, that you have something for them, that you're going to be able to do something? Because my claim is that you're not going to. And even if you have some theory of physics that is completely compatible with everything that's going on, it's not enough. That's not specific enough to enable you to solve the problems you need to solve.
I don't think this is controversial at all, or insightful, I'm afraid to say. I mean, again, it's as if to say, if someone was to ask, can you explain to me the causes and consequences of World War II, to begin with, well, the standard model of particle physics tells us that quantum field theory is basically about general relativity. Well, that'd be ludicrous. It's not where you begin, it's not where you end, and you probably wouldn't even mention it whatsoever throughout your discussion of the causes and consequences of World War II. No, and so too, in fact, with every other subject that's not physics. So yeah, maybe they're arguing it's a straw man. There might be some physicists out there, but you don't hear them. I don't hear them anyway. That physics is the only game in town that it will be able to explain everything. When it comes to explaining the particular things they talked about there, the origin of life and intelligence, well, one thing to say is he's going to talk about the origin of life, and he doesn't really think it's almost like he talks about it as if it's a pseudo problem, because there's no place you can point to where, again, either side of the line, this thing is non-living and living, and so therefore talking about the origin of life is like a pseudo problem. What we're really talking about is increased complexity. Okay, whatever. As for intelligence or this creative algorithm, or however you might phrase it, yeah, maybe the answer comes from physics, maybe it doesn't. Anyone who insists either at this point, I think, is speaking on things they don't yet have the answers to. It's okay to say we don't yet know. But in that situation, often what it points to is a deep philosophical issue. The philosophical issue being, where will the answer come from? Will it be from computer science? Will it be from physics? Will it be from some other area of science hitherto unthought of that might be relevant to something like intelligence, like physiology or evolution by natural selection, or who knows what? Who knows how we might figure all this stuff out? But yeah, who's arguing that it must come down to, especially intelligence? I've never heard anyone say, well, it might come down to particles and fields. That's how we explain intelligence. Maybe Lee Cronin says something like that. I don't know.
In the end, when you need to solve those problems, the person you're going to go to is not a physicist. It's going to be either a biologist or a psychiatrist, or who knows, but it's not going to be a physicist. And the simple example is this. Let's say someone comes in here and tells you a beautiful mathematical proof. Okay, it's just really, deep and beautiful. And there's a physicist nearby, and he says, well, I know exactly what happened. There were some air particles that moved from that guy's mouth to your ear. I see what goes on. It moved the cilia in your ear, and the electrical signals went up to your brain. I mean, we have a complete accounting of what happened, done and done.
Yeah. Okay, so this is the coperatum argument, right? But I don't actually hear anyone say this anymore. Not really. I mean, it was a common thing a couple of decades ago, I suppose, where Sam Harris would talk in these terms that really the fundamental thing is physics, and eventually we'll get everything out of physics. But I think even he's changed his tune now. Everyone knows that physics cannot possibly provide answers to everything to history and economics, to whether or not there's alien intelligence out there, and of course to why it is that a particular proof in mathematics is beautiful or not. The reductionist account can be true and vacuously true, but it won't be a good explanation at the correct level of understanding why is that particular mathematical proof beautiful or elegant or more elegant than something else. That requires an explanation from a mathematician in terms of what elegance is, but it won't come down to, as Michael said there, the vibration of air particles.
But if you want to understand what's the more important aspect of that interaction, it's not going to be found in the physics department. It's going to be found in the math department. So that's my only claim, is that physics is an amazing lens with which to view the world, but you're capturing certain things. And if you want to stretch to sort of encompass these other things, it's just we just don't call that physics anymore, right? We call that something else.
Okay, but you're kind of speaking about the super complex organisms. Can we go to the simplest possible thing where you first take a step over the line, the Cartesian cut, as you've called it, from the non-mind to mind, from the non-living to living? The simplest possible thing, isn't that in the realm of physics to understand? How do we understand that first step where you're like, that thing is no mind, probably non-living, and here's a living thing that has a mind? That line. I think that's a really interesting line. Maybe you can speak to the line as well. And can physics help us understand it?
I think that line is interesting as well. Even if you can't point to where the line is, that doesn't mean there's not a line. Or that there are things with, perhaps, I like to say that people are the entities with minds. Minds are the form that can have self-similarity with the rest of physical reality, that we can model and explain, most importantly of all, the rest of physical reality. We have universal minds. So it's the universality that's really important. And the reason it's so important is because ultimately it will become cosmically significant. If you're going to explain why it is that there's a space station on the moon at some point in the future, put there by the Americans and Elon Musk or whoever else, then you're going to be referring to the action of these universal minds. Now, you might very well say, okay, well, maybe dogs have a primitive form of mind that's not universal. And maybe cockroaches have another more primitive form of mind that can do even less, has a much smaller repertoire of possible things that is going on subjectively. I don't think that's the case, but I can't prove it. I can't prove that my idea, I'm not alone in this, that only human beings have explanatory creativity, only human beings have consciousness, only human beings have minds, and the word mind referring to that capacity to explain things in a universal way, the unique property of human mental psychology. So if there are subjective things going on with other animals, okay, I will concede as soon as there's a good explanation of that. I think, again, as David Deutsch says in the beginning of Infinity, just err on the side of caution. We don't know if dogs and cats and cockroaches can't suffer. So given that we don't know because we don't have a good explanation, we should be careful. Don't go around torturing animals, for example. So I'm all on board with that. We have a problem of what this mind is, and we have a problem of why it is that some living creatures actually exist, that there is this issue of molecules that are able to be replicators. Where do they come from? And it's interesting. It's a genuine scientific problem. And I think it's quite right that people do Miller-Urey experiments to try and figure out how you go from non-replicating molecules to replicating molecules, and then to cells and to more complex organisms. And there's a lot of open questions here in biology and evolutionary biology, of course. There always will be. But let's hear what Michael's going to say about this problem of the distinction between the non-living and the living and the non-mind and the mind, and see if it clarifies things, confuses things, or doesn't add anything. Let's see.
Yeah, let's talk about, well, first of all, of course it can, meaning it can help, meaning that I'm not saying physics is not helpful. Of course it's helpful. It's a very important lens on one slice of what's going on in any of these systems. But I think the most important thing I can say about that question is I don't believe in any such line. I don't believe any of that exists. I think there is I think it's a continuum. I think we as humans like to demarcate areas on that continuum and give them names because it makes life easier. And then we have a lot of battles over, so-called category errors when people transgress those categories. I think most of those categories at this point, they may have done some good service at the beginning of when the scientific method was getting started and so on. I think at this point, they mostly hold back science. Many, many categories that we can talk about are at this point.
I agree that, yes, these categories sometimes have caused scientists to be fixated on certain things that aren't really important. You know, one category might be planets. What is a planet? Now, it's just a matter of definition. It's not a real thing that's out there in, kind of reality. It's just what astronomers impose on reality. They define a planet into existence as an object that orbits a star. That's a problem. But anyway, an object that orbits a star, an object that has cleared its orbit, which means it's not crashing into other asteroids or comets as it goes around its host star. And finally, it pulls it, its own gravity is sufficient to pull itself into a sphere. Okay, and it's not orbiting another planet, because if it's orbiting another planet, then it's a moon or a satellite, if you like. Now, this idea that this is what a planet is, well, that doesn't have to be what a planet is, but, it can be helpful and sometimes it can also mislead. There are these things called rogue planets that actually, for whatever reason, perhaps the supernova went off and it blew the planet out of orbit and they can go wandering through the galaxy, not orbiting a star. So what do you call them? Well, you put the prefix rogue or something like that. And so astronomers think these things exist, that there are planets not orbiting stars. But if they're not orbiting stars, then according to the International Astronomical Union's official definition of what a planet is, they're not planets because they're not orbiting stars. So all of that, debate about words are pointless. It doesn't really help advance science. It's not solving a problem to actually settle on what the definition of a planet is. But to say everything's a planet would be also ludicrous, right? It doesn't help to say, well, we can't draw a line. We can't draw a line between a single free electron going around a star and a whole other star going around a star. And because we can't draw a line between those things, then therefore everything's a planet that orbits a star. Or everything in the universe is a star because we can't draw lines and these categories are misleading. Well, no. Not everything has to be a continuum, and sometimes it's very, very useful to distinguish between these different entities to understand them. For example, a star is a thing, generally speaking, where the mass is sufficient such that fusion reactions begin in the core of the star. And so you end up having nucleosynthesis. So fusion reactions distinguish between stars and non-stars. So the gas cloud before it is a star is just a gas cloud or a nebula. And then it condenses and the fusion reactions ignite, at which point it's a star. And then eventually the fusion reactions end and then it becomes a dead star, like a white dwarf. A white dwarf is sometimes referred to as a star, but if there's no fusion reactions going on there, technically it's a dead star. And a pulsar or a neutron star is also not a star, it's a dead star. Like a black hole is a dead star. But it's certainly the case that planets aren't stars. And how you go from the planet to the star, okay, there is kind of a continuum, but there is a flash point. There is a particular mass where a big gas giant like Jupiter, if you were to continue to add more and more hydrogen and helium gas to something like Jupiter, there would come a point at which the fusion reactions in the core would commence. And at that point, you would say that it's a star. And that's a useful distinction to make because then it's producing lots more energy than what just thermodynamic compression would be called, because Jupiter actually does produce more energy than what it gets from the sun because you just compress a gas and it heats up and so on. But it isn't shining for the same reason that something like a star is. So some of these distinctions are useful. Now, when you get into, okay, living versus non-living, and you go, well, I can't point to where the place is between, non-living stuff like a carbon atom or a chain of carbon atoms and something like a cell, which is absolutely living, because I can't say where the living replicators begin, is it DNA, is it RNA, is it something more primitive still, then therefore it's a pointless question to ask. Well, it's not a pointless question to ask, even if you can't point to where it is. These are sometimes called Socrates problems, or the problem of the heap. Is Homer Simpson bald? He's got a few, hairs there. Most people would say he's bald, even though he has some hair. And most people who are regarded as bald have some hair. So having one hair on your head does not make you non-bald. Having zero certainly does, but but it doesn't mean that the term bald is meaningless. In the same way, the term intelligence can still mean something, even if we cannot account for precisely where it begins, and the same as living and non-living. Anyway, let's keep going.
Very harmful to progress, because what those categories do is they prevent you from porting tools. If you think that living things are fundamentally different from non-living things, or if you think that cognitive things are these like advanced brainy things that are very different from other kinds of systems, what you're not going to do is take the tools that are appropriate to these to these kind of cognitive systems, right? So the tools that have been developed in behavioral science and so on, you're never going to try them in other contexts.
So this is where I think, there can be some benefit to this, like, more power to creative out-of-the-box thinkers. So if you genuinely think that everything can think, everything has intelligence, everything has consciousness, then of course it makes kind of logical sense that you go, well, what tools, intellectual tools, have hitherto been used to investigate the contents of consciousness? Why people behave the way they do, how thinking works and all that. And most people think, well, that's the domain of psychology, or psychoanalysis is what Michael comes back to. Now, never mind that many of us think that rather a lot of what passes for psychology and psychoanalysis is junk. Some's good, but, there's a whole lot that's junk. Now, if you have a subject area where a whole bunch of it is junk, almost worthless, why you'd want to apply that then to other areas as well, or use the language of those areas, like language of psychoanalysis, and apply it to chemistry, biology, physics, I don't know. But, again, this is the motivation that he has for saying, well, we can't draw a line between the intelligent and the non-intelligent, or the living and the non-living, because he wants to be able to apply psychology in a certain sense, the language of psychology, like cognition, to all these other things. So everything is able to persuade or be persuaded. Everything has a level of cognition associated with it. Everything has a level of consciousness and intelligence associated with it. And there's no bright line between the things that possess those attributes and those that don't. After all, everything does. It's just a matter of degree. Maybe everything's alive. It's just a matter of degree. But that doesn't help with solving the problem of why some entities, call them living organisms, like cells and birds and bees and people, are qualitatively different in a very important way to something like an atom of carbon. There's something that's different between those things. And to say that they're all similar in these particular ways doesn't help. Anyone can point out all the ways in which, given two things, what are the similarities between them? But in order to explain the differences, one needs to acknowledge that there are differences. And so that would be my comment on this. Yeah, we're all made of matter. Everything's made of matter, for example. Human beings are made of matter. But that doesn't help to explain what a human being is. And just pointing to the fact that an electron is matter, an atom is matter, a complex molecule like DNA is matter, and people are matter, it achieves nothing in explaining what the differences between those things are. Science should focus on the differences sometimes because it helps to illuminate what the problem is. Why is this thing like that, and why is that thing a different way? And then explain those differences. Explaining the similarities won't get you there. Let's keep going.
Because you've already decided that there's a categorical difference, that it would be a categorical error to apply them. And people say this to me all the time, is that you're making a category error, and as if these categories were given to us, from on high, and we have to obey them forevermore. The category should change with the science. So I don't believe in any such line, and I think a physics story is very often a useful part of the story, but for most interesting things,
Okay, so I think I'll leave it there with the Lex Fridman interview for now. So he's obviously getting pushback. People are telling him he's making category errors. He doesn't believe in these categories. He doesn't want the categories and so on and so forth. But, okay, fine. But simply dismissing the categories for a continuum doesn't help us to understand the differences, because all we're doing is highlighting the similarities. And what we want to understand is sometimes there genuinely are qualitative differences. There are qualitative differences. And I want to stand my ground on this because, again, it's this attempt to say that there's nothing special about human beings. We're just part of the continuum. But there is something special. And to try and understand what that special thing is to understand the qualitative, categorical difference between humans and other things. In whatever way you want to phrase that, if you want to say that the difference between humans and other things cannot be that we're made out of matter. Tick, correct, I agree with you. It cannot be that we are alive because, tick, obviously, okay, that's not the thing that makes us special, because there are lots of living things. But there's something that makes us special. And if you want to say, well, I'm also going to rule out that it's intelligence or agency or the ability to persuade and be persuaded, let's say, however you want to couch that, fine, but now I'm still left with the problem of how can I even begin to describe this issue? Because you're saying you can't use the word intelligence. You can't say that people are special because they're intelligent. Because guess what? Dogs are intelligent as well, and robots are intelligent, and even cells are intelligent. This, by the way, is one of my favourite lecturers that I've interviewed on my own podcast here before, Charlie Lineweaver. We had a good argument over lunch one time, when I think we had an argument on the podcast as well, precisely about this. He wanted to say, well, everything's kind of intelligent. There's intelligence everywhere, and people. This is the old. People are unique. This is his mantra, Charlie Lineweaver. People are unique. Humans are unique, just like every other species is unique too. Of course, my retort to that is, no, not just like every other species. Yes, every species is unique, but we are unique in a special way. And he says, of course, to put his argument in his terms, is to say, well, that's only because we have big brains. We have big brains, and so we want to look around at the universe and think that our brain's so special, and that this is somehow more important than if the cow could think. The cow would conclude that, well, producing milk is the most important thing. We're milk producers, and so we're kings of the universe. But that's just not true, because the universal brain, the universal mind, is the very thing that allows us to change the course, not merely of our own history, but of the entire cosmos, which is a very significant thing. And so that's why this is so important. Let's move on to the next interview.